Hello, can you?
Yes, I can hear you now. I think everyone is in.
Okay,
We need to refresh the browser. So log in again. So we can start. Yeah,
I
everything is
think
good.
there was some bug.
Yeah, some bug. Yeah, that's why testing is very important.
Yeah, so I'll inform them that.
Hopefully, this way we had something from the conference and then apply to their workflow.
Yeah.
This was very strange.
Yeah, it's
This
working now.
didn't happen.
I think there's some bug. So
There
it
is some
crashed.
bug. I think now it's okay, right?
Yeah, it's okay now. Everyone is in now. Let's wait for John to join.
Okay.
Or
we won't ask John to share his screen, okay? Because it happens when he tried to share the screen. I don't know how he and if it's related. Maybe not. But
that's fine. Yeah, I see John Micco here. He's in now. Okay, so
yes.
yeah, so let's. Sorry for the technical problem. Hopefully, we don't have it anymore. So let's start with the second keynote today.
Yep.
So yeah, I would like to welcome John Micco today. So John is.
Oops. I'm a print.
Your video is frozen.
Of how industry actually doing testing and how it connects to the academic area. So John worked a lot on 20 years. He was at Google. He owned the developed the Google CI, which is used by anti-Google engineer, like 40,000 engineers sharing the same system. Yeah, that is like the biggest one. And the second one is Facebook, like 10 times less. Right. So yeah. So let me start the video, and then people can ask questions live in the chat, or you can ask after the talk.
Good morning, everyone. My name is John Micco. I'm here from VMware to give this talk about CI and CD. What I've done for the last
Right. Thank you, John. It's a very interesting question. Very interesting presentation. Yeah.
Yes, I have a question.
Go
Sure.
ahead. Yes.
Hello, John. Can you hear me?
Yes, I can
you
hear you
all
just fine.
All right. So, I mean, this is very interesting topic, and it has applicability in industry, obviously. And the taste, and you were mentioning the flaky tests, and obviously, from what I understand, is that the flaky tests happen or they occur because every time you run the same version or same configurations, one time it runs successfully and then one time it runs unsuccessfully, same parameters. But is it possible that one of the reasons why these flaky tests really happen is because of some kind of outside constraints that are not related to code transitions and all other parts of code, such as, for example, let me think about, because you're doing this at the runtime. So is it possible that when the code goes through some functionality, it may take, let's say on the first pass, it takes 10 seconds to run one functionality, same functionality, but on the second run, for some reason, it takes 15 seconds. And for that reason, because the other function is expecting the output in a certain time frame, then these kind of flakes may occur. And these are things that probably cannot be easily captured because it's all in a runtime. And this also reflects performance concerns. So that, like, do you have any idea? Maybe could this be one of the reasons? This is just my thought process, but I'm not sure if I'm in the right direction.
It is certainly true that one of the most prevalent causes of flakiness is timing issues. And it's funny, one of the things we observed very much at Google and also at VMware, we remember I talked about how we load up our testing systems with high CPU utilization and high memory utilization, lots of contention for this core. What happens in such cases is tests run at a different pace just because the machine is either more heavily loaded or lightly loaded, and that can cause race conditions with the test. Maybe it's not interlocked, maybe it says sleep 5, and if you ever see it, if you're reviewing a test and it says sleep 5, you want to tell the author that that's not a good test, right? because it's likely that that's going to cause a flake at some point. So yes, and the other thing that you mentioned in your statement there, which I'll also key on, is it's not just timing related. So anything that you don't control over, right? So for example, in our testing pool at VMware, we're using, I don't know, 7 different machine configurations and profiles and different kinds of hardware and software layer that can interfere or affect the way a test works. We had some test flakiness there that was caused whenever this test ran on one of these machines, it would always fail. Whenever it ran on one of those machines, it would always pass. And depending on which machine you got, it would either pass or fail. And it looked like flakiness to the test author, right? It fails sometimes and it passes sometimes because we weren't controlling for which machines it was getting. And if it got one of the bad ones, it would fail. And if it got one of the good ones, it would pass. So guess what? We started controlling for that. We only let that test run on the machines where it would work and got rid of that flakiness, right? So there's all kinds of examples of things like that. Also, not everyone controls all of their library dependencies, like which browser might be installed on a machine might be different. All of those kinds of things can kind of impact your testing and make it flaky. So there haven't been I'd say there haven't been enough studies of all of the causes of flakiness and what they do. We need more work in that area. But it's in fact many people in academics don't want to study this because they believe that the test should be deterministic and that there shouldn't exist any flaky tests. But none of the testing systems I've seen at scale can actually eliminate it as a cause.
Right. Well, thank you. And this is another follow-up, though. So does this mean that maybe researchers have to, because all of the constraints that you've been mentioning, probably just the race condition and perhaps portability issues with some extra devices added to the system and all kinds of stuff, these mostly, to me, seem to relate to non-functional concerns of the software.
Yes.
Which I have seen that a lot of researchers do work in the area, but not as much as it's needed, because everybody is trying to kind of leave behind the system testing on non-functional requirements, because it's very hard to or feasibly I don't know, they're not tangible because we cannot see them, we cannot touch them. So is it because this is the reason why we still deal with flaky tests, and then researchers are kind of afraid, not that they're afraid, but they're not really willing to go that route?
Think about it. Most researchers don't have a lab with, you know, millions of computers in it that are different. It's harder to study that kind of thing, right? And in fact, they have to do industrial collaboration to get into those environments and actually try those kinds of things. So yes, I think there's a certain reticence to study it. I'll go there a little bit. One of the things that really makes me nervous about things like fuzz testing and things like is because if your test oracle is not stable, if there's any flakiness in your test oracle, then you can drive to totally the wrong conclusions with your fuzzing. It's like, right. So it's like the whole thing is kind of interesting. But yes, in every industrial setting I've seen, it's been a thing that the practitioners have to contend with is this flakiness.
So probably the Google people can I mean, they have probably the infrastructure to kind of guard themselves towards this direction. You know, like maybe to look at this high scale. I mean, I can understand the industry. I mean, academia can handle also the theoretical aspect of it, how if it's going to work or not, and maybe the industry people can make it more applicable. I mean, I worked in industry before too, so it's a little bit different how it works in academia, and it's way different how it works in industry. But I think kind of bridging these two together only on this matter, maybe, you know,
look,
we will be in a,
this
in
is
a
the
good
kind
direction.
of thing. This is the kind of thing that one of the reasons I'm here at an academic conference talking to you at all is because this is something I'm passionate about, and I want to see more academic industrial collaboration on these kinds of things. There's been really good work on flakiness done at Microsoft and Google and Facebook, and they're now starting to write papers about it with you know, students and with researchers. And I think those collaborations have been great for the state of the art. So I just want to see more and more of that. So I'm glad you're excited about it, and maybe you'll come and collaborate with us, and we'll be able to do some nice paper together. It'll be fun.
I have to push my advisor to take the initiative. Thank you very much for your wonderful talk, though. I got some great insights from the presentation itself and discussing with you as well.
Well, thank you. Happy to help.
Yeah, thanks, Vijay. Yeah, that's a very interesting question. I think there's a gap between industry and academia, and that's why we have a lot of industry people in this conference too. Yeah, so let me so like in the comment that interest, like Sigrid had raised a very interesting question. Like we think that like author count also like a good predictor for fall and predicted and flakiness. What do you think about that, John?
So I'm sorry, I was trying to read the comments in the chat while you were talking. Sorry.
Yeah. So the author, the CI, the CI author count also a good predictor for test quality.
Yeah, that's a pretty crazy result, right? It's not. So this is why we one of the reasons why we did this sort of work to try to evaluate regression test selection is because who would have thought that author count was a feature, right? How many different people have changed a file? Like not a thing, but several studies have now confirmed it. Somebody posted in the chat, there was another study that confirmed that same result. And it just, at Google, we actually looked at some of these files that had changed a lot and caused breakages. And most of them were like configuration files, or they weren't code. They weren't core code files, but they were things that could cause breakages to the build system and to the test system. So it was kind of interesting that when many people were changing them, maybe no one is an expert. Maybe people change this file because it's some common thing that they all need to work on. But it was astonishing that was the best feature at predicting whether a test was going to break, was how many, this change, how many authors changed this file. Very interesting to see how that was correlated and how it showed up in our evaluation there.
Yeah, that's very interesting. Yeah.
Mm-hmm.
Is there any question from audience? Yeah, because Secret, she also have a comment on the in the comment. I think that's also very interesting. Yeah, basically, flakiness is something people are aware of, but like people we never publish or explicitly talk about. Everyone experienced it, but like no one.
I want to comment on that a little bit. I think we looked. I mean, I've seen a lot of evaluation of flaky tests, but not probably as much as we should. There's never been. I mean, there's a few studies, some very small studies. Jingzhou Liu, one of my interns, did a study on the root causes of flakiness. But let me say this: the assumption that it's bad test architecture isn't borne out by what I've seen. Oftentimes, in fact, at Google, some of the most persistent low-level flakiness that wasn't very high probability was actually coming from production code. And it was a problem that our customers were experiencing at some very low rate. And we were catching it with tests. I've seen that pattern happen quite frequently. But it's anecdotally, when we did a little study, a small one at Google, we saw that about a third was coming from test code or test setup or test architecture. Like maybe they did a sleep, maybe they didn't wait properly, whatever, stuff like that, timing issues, other things, right? And about a third came from the code under test, which was like, some real problem in your production code that your customers are experiencing. And about a third came from infrastructure, where some thing would happen during the running of the test. Maybe the whole machine would out of memory or who knows what, right? And it would cause a problem. So yeah, I don't think it's just, and in fact at MathWorks when I was there, they took the best developers in the company and put them on a project to eliminate all flakiness. Let's just get rid of it all, right? And those guys went off and they fixed a bunch of things, right? And by the time they were done, we had about the same number of flakes. Why? Because people were inserting new flakiness at the same rate as they were fixing it, and we gave up. So that was, we spent about 6 months trying to fix flakiness, all the flakiness, and couldn't do it. So,
may I ask one more question?
Sure.
So, John, we experienced an issue right when your presentation started. It must have been for a reason. So, do you think that what happened just today, because we were baffled, our team, we were not able to figure out what happened. Everything was running smoothly, and then all of a sudden, abruptly, we were all kicked out of the program. So, do you think this is some kind of test flakiness happening here?
Well, it could be something that wasn't covered by a test, which some such thing could easily cause such a problem, or it could be some kind of flakiness that happens once in a while and maybe isn't being noticed as a real production code issue. I mean, look, both things happen, and I just want to say that I'm not aware of an industrial setting where this truism about flakiness doesn't hold, right?
Yeah.
All
right. Well, I mean, we are not saying that MidSpace is not great. I think so far we have been doing everything right. It's just we've been experiencing some weird issues that kind of intrigues us to find out why.
Yeah, exactly.
So thank you.
You're welcome. Happy to help.
Is there any other question from audience? Sigrid, you want to add something, or yeah, good.
Okay.
Right. So,
well, again, thank you, Bao, for inviting me here to talk. And I always enjoy giving these presentations, and hopefully people got something out of it.
Yeah. Well, I have a question.
Sure. Oh, okay.
So,
good.
Yeah. So in this CI system, basically it's like a traditional CI system when we work with like code system, right? But like, how do you think that's one in evolve with the like ML software? How the CI system?
Well, we need this is a research area, a big research area. We really need a different way for evaluating